Picking up where we left off. Make the ball move. Look fairly smooth. But if we want to keep doing this, we'd have to add more and more lines. That's getting tedious. So I'm just going to get rid of most of these lines. Let's give it a new name. Whoa, what just happened here? Okay, I'm going to make a copy of it. So I'm going to move this change of position line so it's in a better place. So I'm going to put it on line 6. And I'm going to get rid of some of these lines I don't need here. Yeah. Lines 8 and 9, those are the lines I want to do over and over and over and over. So there are 3 things that have to be done. I'm going to put another blank line in here for clarity. I'm going to take out this comment. One thing is the lines you want to do over and over and over and over again, you need to indent them. So if I put the cursor in front of the sleep statement, hit the tab statement. Put the cursor in front of line 10, hit the tab statement. These lines that are indented are the lines that will be done over and over and over and over again. Now, if I run this, you don't see anything, and I scroll down. It says inconsistent indentation at line 6. It's because we did this indentation and it's not quite understanding the full gist of what we're doing, because there's 2 more things we have to do. One is we have to tell it when to stop. So this line 8, this blank line I have up here that is not indented, that will be the line that says, okay, you're going to keep doing these 3 lines until we reach a condition where we want to stop. So there are different ways of doing this. One way is to say, well, we want to do this, let's say we want to do this for 2 seconds. So while time t, I'll call time t, is less than or equal to 2, then that means I'll keep doing this over and over and over and over until time has reached 2 seconds. I'll try to run this. We don't see anything. And when I scroll down, it says the line while must include a colon. That's something you'll get used to eventually. If you forget, it'll remind you. At the end of this line, you have to put a colon. Okay. Now I try to run it. And nothing happens. And I don't see an error. And one problem is it doesn't know what T means. T is meaningless here. So up here, see on line 4, we want time to start at say 0. T equals 0. So this now sets up a place in the computer's memory, calls it T, and it starts it out at 0. Then I also want to say each time I move the little ball, that simulates a certain amount of time passing. So maybe it's going to be 0.03 seconds. But I have to give that a name, so I'll call that dt. So dt equals 0.03 seconds. So now t is the time. dt is going to be the little piece of time that passes between each frame. So now, among the repeating lines, I need to make time pass. So in addition to sleeping, for a little bit of time. I need to say that now the time has increased by an amount equal to dt. If I don't do that, then a bad thing will happen. And maybe I'll show you that at the end. Okay, so let's say this. Run it. There we had the ball. Looks like we had to go a little too far beyond our range of our scene, so I'm going to make the range of the scene a little bit bigger. And there you go. Nice smooth animation of a ball moving a certain change of position each time. Great. Now, for doing physics, usually we don't want to say that the ball moves a certain amount of position change each time. Usually we want to talk about words like speed and direction, or the combination of two, which is called velocity. So usually we want to say the ball has a certain velocity and use that to control the calculations. So that just means we need to make two changes here. One is I'm going to put a new line after the ball, line that creates sphere and calls it ball. I'm going to make a new property of the ball. You can do that. Say ball. It's the name of my object. I want to create a property called velocity, VEL. And we'll do that. That's okay. If I want to set it to equals, well, let's see here. I've been doing a change of position of 0.03, 0.02, a time of 0.03, so I will simply use that to calculate the velocity that would be the same as what we've been doing. Okay, so it's moved a distance. So that's not quite right. Because remember, this change of position is a vector. So what I really need to do is to copy this vector, which is my change in position, paste it here. Velocity is an actual vector. It has an x, a y, and a z. So I need the change in position, the change of x, y, and z, divided by the little change of time, and that's what velocity is. Now down here, that means I don't want to say what the change in position, but I want to use the mathematical equation for the physics, which is that change of position, by definition. Velocity is the velocity times the time that has passed. So I've done this a little roundabout way. I used the change of position I knew I wanted, and used that to calculate the velocity I wanted. Now I'm calculating the change in position again. That's okay, because now I can do different velocities. We'll see what happens. Let's see if this works. And it does. It went a little too... Oh, no, it didn't quite go out of screen. Let's run this again. And there we go. It's a reasonably smooth animation. The advantage of doing it this way is now I can say, well, what if I give it a different velocity? What if I want it to only have a velocity component in the x direction, so the y velocity is 0? So I can just change that. I don't have to worry about calculating the change in position. My computer's going to do that. So I can do that, save early and often, run it again. There you go. I suggest of doing an animation with something that is moving at a constant rate. I did want to show you what happens if you're doing this while condition. In other words, it's going to keep doing this while time is smaller than a certain number, and then we'll stop when time reaches that number. Well, what happens if we forget to change time? So now I've changed that to a comment. So now that changing the time is simply not going to happen. So time will always stay at 0. So what's going to happen? Well, time isn't going to change. Time is never going to reach 2. I'm not going to save this. But I run it, and it just keeps going, and going, and going, and going, and going, and going. One thing you can do in GlowScript is if you hold down both mouse buttons, you can pull the camera back, and it just keeps going, and going, and going, and going. I'm going to add a line down here so I know when it's done. Print done. Remember, a print function will print it out. What's in quotations is text that will be printed out. Let's try to run it. It's running, it's running, it's running, it's running, and it's not stopping. Whereas if I put this line back, actually let time change. And it runs, and it runs, and eventually it stops, and it prints done. So you have to be a little careful with these while statements. If you set up a situation where this stopping condition, T, this is not a stopping condition, it's going to run as long as this is true. So if this condition is never false, in other words, if time never gets bigger than 2, then it's just going to go forever and forever and forever. It's called an infinite loop, and sometimes it can cause all kinds of troubles. So that's the gist of a simple animation, and we shall do more sophisticated animations as time passes. So far we're doing bare bones stuff just to get the very bare bones coding, programming that we need. We'll add fancier features as we get a little more comfortable with the gist of how to actually make this happen.